I am so excited to be here. I'm so honored to have been invited to host a track this year. It has been an amazing day. Who here has been to other talks in this track today? Awesome. Did anyone just go to Crystal's talk? Okay, great. That's good context to have. So ours do relate a little bit. And like Daniel mentioned, I spoke at reInvent a couple years ago, and I'm actually going to kind of take down a little bit what I said at reInvent. So let's set some definitions first on chaos engineering. So who has practiced chaos engineering before at their organization? Okay, not a lot of hands. Has anyone run like a informal game day type thing? Okay, so from the chaos engineering principles of chaos.io, it's defined as the discipline of experimenting on a distributed system in order to see how it withstands turbulent conditions in production. So the idea is that the turbulent conditions are already there, and that chaos engineering is finding out more about them. But it's been a bit misconstrued over the years. As with everything that gets popular in software, it eventually becomes a marketing term, right? And so what I want to talk about today is these different phases of chaos. We have what happens before we do some chaos engineering, what happens while we're doing chaos engineering, and what happens after. And Laura McGuire actually hinted at some of this idea called creating foresight in her talk today. And I'm going to kind of take those approaches and apply that towards chaos engineering right, as well, because really doing chaos engineering is a way that we can create foresight and hone expertise within our organizations. And I want to point out that there is too much focus as an industry on the during part. And it makes sense. You know, we're engineers, we like tools. It's really cool to break things in production. Like, it sounds fun, especially when we can do it safely. However, there is so much more to it than that we're not taking advantage of, and therefore we're losing what we're actually gaining from spending so much time on this tooling part. And I think we need to just stop focusing all this attention on how we can make things fail and break them. Because we miss out on the value of the setup of the experiment and the dissemination of learning outcomes that can bring our organizations and help us level up overall. So as I mentioned, this is a little bit of my background. I've been talking about chaos engineering for many years now, and my mental model of chaos engineering has refined and grown since I first started doing it. I co-wrote a couple books on it. I have a book coming out in April that I co-wrote with Casey Rosenthal, along with a number of contributing authors, where I spend one chapter actually talking a lot about what I'm going to talk about today. I also recently founded a community called Learning from Incidents in Software, and I spent some time at both Netflix, Slack, and Jet.com developing and honing my chaos engineering experience. So I want to set some common ground. The goal with chaos engineering isn't to, build tooling to stop issues or to find vulnerabilities for us. It's to push towards a culture of resilience to the unexpected. And there's a number of ways to do this. Chaos engineering is not the end-all, be-all. And Crystal touched on that a little bit in her talk today. Tools can help with this, sure, but it doesn't stop there. Just because we find things with our tools and just because our tools work in surfacing vulnerabilities, what does that actually mean for our organizations? And that's what we're going to talk about today. So I want to share this quote from Sidney Dekker, David Woods, and Richard Cook. They say, resilience is not about reducing errors. It's about enhancing the positive capabilities of people and organizations that allow them to adapt effectively and safely under pressure. Right? And so given this focus so much on the tooling in the last couple years, I think we've lost sight of this a little bit. We almost celebrate finding vulnerabilities. But what I've seen happen is we don't actually always fix them. We don't actually do anything about that. We kind of clap. And then we move forward. It gets added onto a Jira backlog. and it sits there for 7 months, causing us a lot of anxiety because we know it's in the background, but we don't actually know how to prioritize it. So as I mentioned, I'm going to talk about some different phases of chaos engineering that I don't believe get enough attention today. So let's start with the before phase. So sharing this quick quote from George Box, he says, "All mental models are wrong, but some are useful." Now, this track today has talked a lot about mental models. It's talked a lot about mental model refinement. It's talked about how my mental model of the system is completely different than my teammate's mental model of the system, even if we're just the only two working on this system. So I want to share a story. When I joined Netflix back in 2017, we were building some pretty cool stuff. We had written some white papers about it. It had been featured in conference talks. We had people rolling similar tooling. And so I want to give a quick overview on what we're building, so what we built, so I can set the context for this. We had built this tool called Chap. It was a chaos automation platform. And the way it worked is it took advantage of the fact that Netflix services used a common set of Java libraries. And we essentially annotated incoming request metadata that a particular call should be failed or have latency added to it with RPC calls and what have you. And so here is an example where we were failing a Netflix bookmark service. And the hypothesis was, if bookmarks is down, right, if your ability to save a movie for later is down, that should not impact your ability to actually watch movies. That was always our key heartbeat metric. And so we would take a very, very small percentage of traffic, just enough to get a signal, and we would split it in half. And we would put half of it into a baseline cluster where we wouldn't do anything with it. And then we'd do half of it to a canary cluster where we would either fail or add latency to the call. And we were so confident in this that we did it in production. And we knew that if it did impact this key metric, this heartbeat that I was talking about around play, we would automatically route these people back into the main cluster, and that would happen within a matter of seconds. And so all a user would see, if anything, would just be a blip. But, so when I got to Netflix, a lot of this was built, and we were 4 developers spending probably 95% of our time heads down building this like really great tooling, this really novel tooling. But as Randall mentioned in his talk today, please pop your heads up and talk to users, right? When you're on an internal tools team, you have users. Your users are your coworkers, right? Your users are other teams. And I had this question. I said, who was running these chaos experiments? We built this great system. It could do all this stuff. You know, we were talking about it at conferences. We were talking about it in books. And we were able to safely fail in production. But when I looked at the runs page, I saw that it was really just the 4 of us running these experiments, which is pretty wild because we had expertise in this tooling and how Chap worked. However, that was our expertise. We didn't have expertise in the nuances of the Netflix ecosystem, right? I didn't know the ins and outs of the bookmark service, so how could I possibly come up with the best experiment there and disseminate what I learned to the bookmarks team? Which is why the findings sit on a Jira backlog for a while, because 2 distinct sets of context. And so we had this runs page where you could see who was running our experiments, and we were so proud of what we had built, and we should have been, right? It was really fun work. But what good is it if the only people that are really using it were us? And so we spent a little bit of time trying to get people to run experiments. We'd go sit with a team, we would talk through the tooling and how to use it, and I would watch people's faces get really scared. Because when you go tell a feature development team to fail their stuff in production using this tool you created with honestly a giant, I mean, we were 4 backend developers, but it was essentially a giant form. And one of the questions was, how much production traffic do you want to fail? Apparently people are scared of that question when that's just an open box. So what did we do, right? This was clearly a problem. We were the only ones running, we were mostly the only ones using this tool. It was very hard to get people to come up with experiments and use it. So we attempted to solve this problem in a very common software engineer way. Does anyone have a guess on what we did?
Stickers.
Yes, but no. Any guesses?
Documentation.
We tried to automate it. We said, oh, well, it's hard to run experiments, takes a long time. We kind of also just want to code. Surely we can just spend a couple quarters automating the creation and the prioritization of all the experiments for them, and then they won't have to do it. We were pumped, right? Like this was some really fun work, and I spent a long time doing this. So I started by collecting information about services from a ton of different sources in order to do this. And these different sources were various systems across Netflix. They were also via one-on-one interviews with people. But this was all in the service of putting this in this algorithm that I was working on. And some of the sources were getting the timeouts for services, getting the amount of retries, getting the fallbacks, getting the percentage of traffic it served. And this was all in service of saying, hey, is this actually safe to fail to begin with? And if so, add it to this queue of experiments that need to be created and create it in a certain way and then prioritize it in a certain way. And it turned out expertise on various phases of creating these experiments was all throughout the company. I had to talk to a ton of people, more than I had during my tenure there, just by doing this project. And after doing all these interviews and aggregating all this data and putting it in an algorithm, I realized I now had this very specific expertise, and I did not want it. I did not want that expertise. I didn't think it was actually going to be useful just in my head. And I also had a question, like if I am getting all this data in service of checking if something is safe to fail, and also how important it is to run an experiment on, surely it would be useful for people to just see that information in one place, right? And so I was building an algorithm, but I also just threw it up on a dashboard. This was not the goal of the tool. The goal of the tool was not to create this dashboard, but I figured it would actually be useful for people to see how we were ranking their experiments. And so we called this Monocle. We got cutesy. It was Chap, and he had a monocle, and see optics on experiments. I was very proud of that name. So people could log in and see their application in their cluster and all their services associated with their cluster. Now, all these columns that you see here are things that could potentially be added to a chaos experiment. But this safe to fail X and check, while it looks simplistic, when I showed people their dashboards for the first time, almost every team just immediately opens their laptop and starts diving into their code. Wait, that's not supposed to be unsafe to fail, right? And that was the surprise. And this UI was a direct result of going through the preparation of automating these chaos experiments. I hadn't even started doing it yet. And so one of the funniest parts was we turned this automation on. We only turned it on for things that were already safe to fail. We turned it off after 2 weeks because this actually provided us most of the value that we wanted, was this dashboard. We also could not keep up with the experiment results. Turns out we were probably doing about 4 experiments a day before. And when you do an experiment, you have to go and look at the results, which takes a while. You have to synthesize them, you have to talk to the team about them. And when we put it on automation, we were running about 200 a day, which meant we were looking through 200 experiments. And when you have 200 experiments running, you find a lot of vulnerabilities. And it turns out when you give a team 500 vulnerabilities, they usually fix 0. If you give them 2, they might be more likely to fix them. And so I haven't been on this team in a couple years. I don't know if they turned it back on, but it was off the last time I checked. So I want to really drive this home because the most insightful part of doing this journey was not actually coming up with this automation or coming up with these experiments. It was actually designing it. It was working with the teams. It was getting them to talk about their mental models. It was asking questions in valuable ways and surfacing this information in a common form that everyone could look at. Everyone had different pieces of understanding on that dashboard, but they didn't have this developed view of how it all worked together. But what I really want to drive home with this talk today is we don't spend enough time here. We did write a white paper about Monocle. We wrote a paper about automating the experiments, and we talked a lot about the algorithm, and you can find it. It got accepted to ICSE, and it was cool work. But when I step back and look at the business value it was providing, it was really in that dashboard. It was really in surfacing and disseminating that expertise. And so not everyone is building or buying a tool like this internally, nor should you. Sometimes we're doing game days. And so how do we design a meaningful experiment if we're doing a game day? And the advice I would give here is to focus on the who, the what, the why, and the how, and have this be a collaborative process. All too often I see with multiple companies that they involve just the expert in the game day prep, in the game day room, and they don't invite the new team members. They don't invite the intern that just joined. They don't invite all the people that are going to be on call because why? It's expensive. But they're missing out on a lot of the value. One piece of advice I would have for this would be to pick a facilitator. So in the incident analysis world, we talk a lot about having an incident review or a postmortem done by a third party that has enough expertise but wasn't quite in the action. I would recommend the same thing with chaos experiments. Pick a facilitator that has a technical background but is not on the team. And the reason being is they're a layer removed and they can ask the silly questions. They can ask the questions that the team would not ask themselves. So a big question is, what do we want to experiment on, right? We know we want to do some of this chaos engineering. What do we actually want to run an experiment on? And so, as I mentioned, involve all the people participating in the experiment in the preparation itself. A lot of times I'll see just one-on-one for the prep, and then all of a sudden 14 people will show up to the actual experiment. Because that part's cool, right? That's the part we nerd out on. That's the part where we're failing production. And it can make a fun blog post, right? But the participation part and the planning part is actually some of the most important steps. When I was at Slack, I was leading up chaos engineering and human factors incident analysis type work there. And this team came to me, they said, we want to come up with a chaos experiment on this new system that's being rolled out to prod. Can you help us come up with it? And so I worked with them. I essentially facilitated for them. And we spent about 2 weeks on the prep. And the person that had told me, hey, we're ready for prod, this is just kind of a gut check, came up to me and said, after 2 weeks, yeah, Nora, we're not rolling this out to production anymore. We're not even going to run the chaos experiment on this. We just going through this exercise, we found out that we are not ready. And again, like we did not even need to run the experiment, right? We got the value out of it. And so there's some common questions I could ask as a facilitator to get them thinking about things in a certain way. And these aren't applicable towards every type of scenario or every type of experiment, but some questions you might want to ask, if it's a services type chaos day, you could ask, are there downstream services that you're worried about in your system? Do you know what happens to upstream services if something goes wrong? Do you know what happens when something goes wrong with your services now? Do you have any sort of fallbacks in place for things that are supposed to be non-critical? What do those fallbacks do? Who knows what those fallbacks do? And try to find that boundary for them. And when you hit that boundary, figure out where that expertise lies and bring them into the experiment too. Ask them how those fallbacks could actually impact the user experience. Ask them about recent changes in their system. It's funny, like these seem like basic questions and I've only really asked like 5 of them, but by this point you usually hit a team's wall and they're having to look up stuff and they're learning stuff as they're prepping for this game day that they're gonna run. Some other questions you could ask are, how confident are you in the settings, the configuration settings for your particular service? How confident are you being on call? How confident are you in any of your team members being on call? And this has to be asked in judicious ways. There's also a psychological safety component that's really important. And so sometimes you may want to ask these questions one-on-one. I always also ask, what in so many words scares you about your service? And I keep it purposely open-ended. Because the confidence or lack thereof that people possess is a sign of uncertainty about their own mental model, or perhaps a lack of confidence in the operating procedures. So I want to bring up this story about the Apollo 1 launch rehearsal test. And I've heard the Apollo mission actually referenced so much throughout this conference so far, which is great. There's a lot of awesome case studies in it. But this mission, Apollo 1, was a launch rehearsal test. It was the first crewed mission of the United States Apollo program, and it was the first project to land the first men on the moon. It was supposed to be a low Earth orbital test to launch on February 21st, 1967, but the mission never flew. A cabin fire took place during the launch rehearsal, which killed all 3 crew members that were supposed to fly out. The name command module, the name Apollo 1 chosen by the crew was made official by NASA in their honor afterwards. But one of the things that was interesting about this test was not all the necessary parties were involved. It's just a test, right? And a lot of stuff went wrong. They didn't have rescue, medical assistance, or crew escape teams involved in the planning of this test. None of those people were notified because it was just a test. It went off the rails, the hatch got locked, and everyone inside passed away. And unfortunately, there was no one to call. Now, flipping back to the design of chaos experiments from this story, as I mentioned, you also want to include new employees. This is a good way to get ramped up. It's also a good way to test how you are talking to new employees about your system and how you are disseminating that expertise and ramping them up. Samuel Parkinson gave a great talk today about how they do this at Financial Times with ramping people up to go on call. This is another good opportunity for that. And I want to share this quote from Gary Klein, who's a cognitive psychologist. He wrote this book called Seeing the Invisible. He says the new employee can see the times when the system broke down, but not the times when it worked. How many of you have had a new employee join your organization and they've just been like aghast at a particular part of your system, right? And you're like, you're so cute. It was so much worse before, right? and it's honestly adorable, really. But they're coming in, you know, up in arms, like, how could it possibly be this way? As opposed to novices, experts can see what's not there, including both in your experiments, but keeping psychological safety in mind, making sure it's okay for people to say what they know and what they don't know, will really help increase the ROI of these chaos experiments. Another recommendation I would have, and I see a lot of organizations not do this, is to start looking at your incident data and making some observations around that, because that will reveal some themes around what you might want to experiment on. Laura McGuire gave a great talk today about costs of coordination in software incidents. There's a lot of coordination costs involved in incidents that could indicate that expertise might need to be more disseminated throughout the organization. Or if you're pooling in people that aren't actually on call for a thing, but you need them. You called someone Tim earlier. Tim always shows up. Do we actually record when Tim shows up when he's not on call? Because that's an indication that Tim is an island of knowledge. And what happens when Tim leaves? Do we know how to do those incidents? And so I bring this up because looking at your incident data will actually show you where you have gaps in your organization, which will prompt you, which should prompt you to do chaos experiments there, right? And then you'll know how to prioritize those findings a little bit better because you understand how important they are. But if your incident data resembles the following, how many of y'all have worked at a place that has a spreadsheet with these columns? So this is not actually going to reveal those gaps for you. You need to get a little deeper. You need to ask different questions about your incidents in order to be ready to understand where to do chaos experiments on, in order to understand how to prioritize the findings, in order to understand who to get involved in the room. Here are some different questions that you can ask about your incident data that can point you towards opportunities for chaos engineering. Maybe we ask, which systems haven't failed in a while? Which systems had failures that took us by surprise? We always have incidents that were like, wow, how in the world did that happen? And we also have incidents that were like, yeah, that sounds about right. Which incidents involved unowned systems, or the ones that needed a Tim to step in and resolve, right? Are we recording that in that spreadsheet? Which incidents involved people that had never worked together before? Sam in his talk today said that they resolved this wild issue, and he brought up that part of the reason that they were able to work through it is that the 10 people involved knew each other really, really well. And that's something that's not to be discounted when you're recording this data later, right? What happens when we have people that don't know each other really well? That adds to those coordination costs, and that could point to a place where a chaos experiment might be a good fit to understand this a little bit better. What did near misses look like? Where did we go? Whew, that was pretty close. I'm glad TechCrunch didn't catch that. I am glad that customer calls did not go off the rails. And which ones involved difficulties in even figuring out what was going on? I have been in incidents where we're sitting for 14 hours trying to figure out what in the world is even happening. And then when we get to that point, it's kind of easy to fix. But are we measuring like that point? Because that also tells us something. Resilient organizations don't take past successes as a reason for confidence. They instead use them as an opportunity to dig deeper and to understand how they work. I want to come back to this because how teams decide what to experiment on, how they use all this data and all this prep and all this setup work is just as revealing, if not more revealing, than the experiment itself. I mentioned that story at Slack where they said, yeah, we actually don't need to run this experiment, and we're not going to release this when we thought we were. Right? That's revealing. And it's okay. It's a good thing. You're getting ROI, you're giving ROI back to the business. When you get to the point where you do define a chaos experiment and you decide, hey, I'm actually ready to run this, like, we feel good about this. You want to discuss scope. You want to say, how do we define a normal or good operation? Where are we actually injecting the failure? We want to say, what do we expect to happen? What do we expect from individual components? What do we expect as a whole? How do we know if it's in a bad state? I see a lot of people do chaos experiments and kind of just use their normal dashboards. And Crystal talked about in her talk where she saw this dashboard once that had like 50 tabs on it. And she was like, I didn't even know where to look. I see that a lot, this dashboard hygiene. And so that is something actually you should reveal in your chaos experiments. If it's hard to figure out what is going on, that's a signal that maybe something should improve. And with all this in mind, how are we actually observing the system? How are we limiting the blast radius if something goes off the rails? And what is the perceived business value of the experiment, right? Let's tie this back to the users, whether it be our coworkers, whether it be our end users. What is the business value of this experiment? And how does the rest of the organization perceive it? Is that different than how I receive it? Is it different than how the team that's creating it receives it? And then up next, hypothesize. Actually state what you think is going to happen. If we fail X part of the system, then Y will happen, and the impact will be Z. So we've set up our plan, we've involved all the parties, and we move on to the during phase. Now, when I was first getting started with chaos engineering, and I tell this story a lot, I was at a company called Jet.com, and our marketing team was crushing it, right? We had a lot of traffic to the site, but we were also going down a lot. And so we were spending all these marketing dollars, and yet we were going down the first time people access the site. And so we created a chaos monkey. It was pretty simple. And I asked folks if it was okay to turn it on in the organization. Everyone was like, yeah, sure, it should be fine. We started in QA, had enough foresight to do that. But I didn't get like a lot of input from folks. And we turned it on, assuming that everything was going to be good, and actually took QA down for an entire week, which significantly impacts the business. Luckily, the chaos program survived past this. We improved from this. And we learned how important it was to actually involve people in these experiments and ask certain questions. And again, it was way more about the culture and the people and the setup and the dissemination than it was about this tool. Although, again, the tool was fun to create. At Netflix, we had graphs like this. So I mentioned that baseline and canary cluster before, and we would actually add canned graphs onto every experiment where a user could track the experiment or the canary cluster versus the control, the baseline cluster. And if those deviated too far on certain business metrics, the experiment would automatically shut down, right? We had built that sophistication into the system, but it was important to look at this afterwards, like, oh, this thing clearly affected downloads, or this thing clearly affected license requests. So if you are doing more of a game day type experiment rather than a tool type experiment, it's good to have roles too. It's good to have specific roles for people. And these can these can change a little bit and be a little bit fluid, but talking about this beforehand will help you set it up, will help you be organized about it. So having a designer, the person leading a discussion, a facilitator, person keeping everyone on track and asking those questions, the person executing the commands actually on the command prompt or whatever tool you have, a scribe taking notes on what is occurring in the room and keeping everything on track there so that you can disseminate it afterwards. An observer that is looking at and sharing relevant graphs with the rest of the room, like, hey, I see this thing or this thing. And then a correspondent whose pure job is to just talk to the folks that are on call, the rest of the business, to say, yeah, we're running a chaos experiment right now. I've seen incidents come up while these are happening and those two parties not talk. And a lot of confusion has happened as a result. And so having that be a particular person's role is also very important. The principles of chaos.org also talks about steady state. It's so important to have a steady state in our experiments. Like what is our normal operation? What's our good operation? What's standard? Not like what is our North Star, but what's normal? Answering this question is actually kind of hard. And it's very interesting to ask it to different people in the room because you might get different answers, which might be an indication that you should not run that experiment. Don't be lenient about this definition. Like, oh, okay, we're all on the same page now. We can just do it. Because you've set up the tools at this point and you're just excited to run it. But you really should not be lenient about this definition. You should figure out how and why it is that these definitions deviated so much from person to person or team to team. So I want to go back to that Apollo 1 story. The morning of the tests, the crew suited up and detected a foul odor in the breathing oxygen, which took about an hour to fix, right? Things were a little bit off. And then the communication system acted up. Shouting through the noise, Chris invented, how are we supposed to get to the moon if we can't talk between 2 or 3 buildings? This was really sad. It was really devastating. But there was a lot that went wrong that morning. But they had invested a lot of time in this test. They had a production deadline on when they were going to get to the moon. And I'm sure we've all been in those places before with a lot less risk. So let's go to the after, because this is one of my favorite phases too. And this is where things relate to incident analysis. It's disseminating what we learned, right? So often we find this vulnerability, or we don't find anything at all, and then that knowledge just stays within the team that was in the room, right? It doesn't really go past that. We don't have systems that help us disseminate that knowledge, that help us tell these stories. And John Allspaw says one of my favorite quotes. He says, resilience is the story of the outage that never happened. And if resilience is the story of the outage that never happened, then what story are you actually telling? And who is there to hear it? Is this stuff you're keeping track of? It's really, really important, right? Who's reading this? Who's grokking it? How are you disseminating some of this? What good are chaos experiments if the only knowledge gained is actually from those in the room running the game day? And if you're measuring who reads and hears and acts on these themes and maybe even correlates them to incidents, that's how you know you're successful and you're growing. It's a very, very, very tricky part of chaos engineering. And the tools in the market today do not focus on this part. Because you also have to make it a story that people want to listen to. So it takes time to develop good storytelling skills as an engineer. Build an internal brand around it. We had one at Netflix that we called How We Got Here. We used to do it with incidents. We would share a How We Got Here story. And we'd kind of take the reader through a narrative, kind of read like a ghost story where you're watching the protagonist go in the house and you're like, why are you doing this? Obviously, this is a horrible idea, but that keeps the reader interested. And that's how we disseminated this expertise. We got everyone reading these. We had people on non-engineering teams reading these because they were interesting. We spent a lot of time on them. Asking better questions after these things happen will lead to better stories too. So forget templates on this. You don't need like a game day template. But there are some things that you can ask, like what did you experiment on? Why did you experiment on it? What were the reactions? It's kind of a qualitative metric. Were people scared about this? Were some people like, yeah, that's fine? When I did that experiment at Jet.com, it was kind of a lack of concern, right? But then it led to this massive thing. And talking about that gap is really, really important because why did that gap exist to begin with? What was surprising? What was new? What mental models got recalibrated? Getting people in the room to share what new things they learned is really important, and you can capture these things in reports. And people get really excited about sharing, like, oh, I didn't know it worked that way, or I didn't know Joe knew this thing. Like, how did he find that graph? Those are really, really great things to mention. What were the necessary adaptations? Did things degrade or collapse at any point? Again, when was the last time people worked together in an incident? Have these teams worked together before? Were you doing this experiment because they hadn't worked much together before? Or maybe there was previous tensions between these two teams. Who was present, and how did we assess ourselves? How did we decide that, yeah, this went well, or no, this went off the rails? And how long did it take to find the right graphs? This is the big one. And who knew? I have been at a few organizations where someone will share in an incident like Tim's magical graph. And everyone's like, Tim, thank you so much. And no one questions like how he created this magical graph. It's just Tim and he's magical, right? So we can't actually learn that. But figuring out like how Tim knew to look there, what he drew on from before is really, really important. And looking at what actually went right in a chaos experiment will help us understand what went wrong. So don't just talk about things that went off the rails. Talk about what went really well, what was exciting, what surprised us in a very positive way, in both terms of technical and human. The pursuit of success, what did we learn that we are actually really good at? Something Sidney Dekker says. And this is where we kind of can bridge chaos engineering and resilience engineering, but still they are very distinct things. We should focus more on what we learned we're really good at, not just finding these vulnerabilities. So we can leverage chaos engineering to measure the sources of resilience and create feedback loops that enhance an organization's ability to monitor and revise their mental models, target safety experiments, and build expertise. Build and disseminate expertise. But in order to sustain a chaos program, I do think there needs to be an upfront investment in incident analysis. Otherwise, you're just kind of almost over-indexing on the most recent bad thing that happened. Where you kind of, yeah, this sounds right today, right? If you invest deeply in incident analysis and looking at your themes, looking at how things are going, you will have a better understanding of where your gaps are. And these reports can actually be used as a cultural artifact. One of the things I was really surprised by at Slack was that these reports were read a lot by new hires, which was something I didn't expect. And it helped them ramp up. It helped them get to know their teammates. It helped them get to know surprises. And it helped them ramp up quicker and ask different questions than they would have otherwise. I see a lot of chaos engineering and incident space in general get measured by the count of incidents, which is a really shallow data point. It makes intuitive sense why our heads go there, right? It's a top-level metric. It's what the business pays attention to. But there's so much more to it than that. And it's not actually learning. and looking at these shallow metrics, we won't actually be able to improve, right? There's no possible way to attribute the reduction in incident count to chaos engineering experiments. There's so much that goes into it. And just stop counting incidents in general. I know that might be a hard sell for your business, but there are a lot more ways that we can learn about how we're doing. Darrell Huff wrote this book in the 1950s. It is still super relevant today. It's called How to Lie with Statistics. And it illustrates outlining errors when it comes to the interpretation of statistics and how these errors may create these incorrect conclusions or these kind of safety blankets for us that lead us to believe we're performing much differently than we're actually performing. So I want to go back to this creating foresight. We've talked about a bunch of different phases of chaos today. And if I can leave you with some key takeaways, it's that you can't shortcut resiliency by buying or building a chaos engineering tool. You just can't. Safety should not fall on just ops or reliability-focused teams. You shouldn't give new employees vulnerabilities to go through and fix. I also see a lot of organizations where when this ends up on their backlog for a while of vulnerability, and they don't know when to fix it, they think it's a good idea to give it to a new hire when they join as a way to ramp them up. That's not a good idea either. Use these write-ups as learning opportunities. Disseminate them throughout the organization. Keep track of who's reading them, because that's really interesting. Connect all phases of chaos and include incident data as well. Purchasing a chaos engineering tool before you've invested in learning from incidents will actually hurt your chaos program. And the chaos tools in the market today don't address these concerns. If you want to chat more about some of this, you can reach a few of us at hello@jolly.io or the Learning from Incidents website, where we've open sourced a lot of these learnings that a few of us have been going through for several years now. Thank you very much. Happy to take questions. I think we have 3 minutes. I don't think we have a microphone.
Sorry. Repeat the question.
Yeah, I'll repeat the question.
So you emphasize the importance of having an intern or junior engineer take part in this, and that the preparation for the experiment is one of the most valuable parts.
Yeah.
So would you say then, if that intern or junior engineer says, hey, I don't actually have a mental model.
Yeah.
The docs, it's not clear where they are. Would it be useful to essentially do a chaos engineering thought experiment? Write out the incident report after the fact with all the characters and everything as the way of
as if it actually happened.
As if it actually happened, as the way of onboarding before you have all these documents that somebody can come in. If you're introducing.
Yeah, so I'm going to repeat the question just because we don't have a microphone. So essentially the question was, I focused a lot on inviting new employees or interns into the room as well to get their mental models. And it was a really good question. What if they don't have a mental model yet? They might not. But stating what they do learn, I'm guessing it's not their first or second day. In that case, it would probably be more of an observational role. But a newer employee that's been there a few weeks or a month, I would actually recommend asking them first, what are your thoughts on this system? What have you learned so far? And not having anyone else talk or chime in. And that's when you're actually going to learn things about how they're grokking the system immediately upon joining, what they're afraid about, what is maybe not getting disseminated to them, and if that is, which it will be, how that is different from the more tenured engineers in the room, the more tenured folks in the room. Did you have something else you wanted to add to that?
What's a good way to make that psychologically safe for them?
Exactly. And so that's a tough part, right? And psychological safety during this, I could make a whole separate talk on that. It's a big topic, and it's really important. This is why, so at some organizations, it's not psychologically safe to do that. I have been at organizations where it is, and I understand that's a rarity, but I've also been at organizations where it's not. In the organizations where it's not, it's really important to have a facilitator that is just trusted throughout the organization, just someone that's not going to judge, someone that's well-regarded, someone that people can come to, and have that person have a one-on-one with some of these newer engineers before they enter the room, and know that what they say is not going to be used against them. This is something that we do in incident analysis as well. I am getting the red stop sign. I am happy to chat later. I will be around tonight. Thank you so much.